Yes, next we'll move on to the next sum. So this they have asked you to calculate the current through 5 ohm resistor. This is also a university question which has been asked in the exam. So I have redrawn the circuit here, the same circuit. Since the current direction is not given, so I have assumed the direction of the current to be in the clockwise direction. So this we have assumed as a mesh 1. Okay, this is mesh 2 and this is mesh 3. So let I1, I2, I3 be the mesh currents. So from this circuit, what do you notice? From the mesh 2, only 5 amp current is there, right, in the mesh 2. So this 5 amp current. So we can write I2 equals to 5 amps. Okay. And you can see in the mesh 3, there is a Ix flowing here. So Ix is equal to I3. So this is from the circuit. Now what we will do, we will apply a KVL to the mesh 1. So when I apply KVL to the mesh 1, so from here, this point, what I will do, so current is flowing in the clockwise direction. So this point will become plus and this point will become minus. So this is plus with respect to the direction of current, this is minus. So it is minus 5I1 and this is from plus to minus it is going. So it is decrease in the potential. So minus 2Ix. Okay, then there is a 5-volt battery which is from plus to minus we are moving, so it is minus 5 and minus 2 here, minus 2 current we are going in the direction of current I1. There is one more current coming in the opposite direction which is I2, so it is I1 minus I2 in brackets. So this is equal to 0. Now we will simplify this. Wherever there is a Ix, we will put the value of I3, we will substitute. Okay, wherever there is Ix, we will put the value of I3. And wherever there is I2, we will put the value of 5. So when I simplify, it will be 7I1 plus 2I3 is equal to 5. Similarly, applying KVL to the mesh 3. Okay, KVL to the mesh 3 will start with this 5 volt. Okay, it is going from minus to plus. So it is plus 5 minus 3I3. Okay, and there is here resistance of 20 ohms. Okay, this is a resistance of 20 ohms. So 20 into, we are going in the direction of I3. So it is I3 minus, there is opposite I2 coming. Okay, so minus I2. Again, I3 we will substitute, I2 we will substitute the value of 5 amps. Okay, so there is only I3 is a variable. From this equation, we will get the value of I3 to be 4.56 ohms. 4.56 amps. Okay, so by putting this value of I3 in the equation number 3, I get the value of I1 to be minus 0.59 amps. So this is actually the current through the resistor 5 ohms which is flowing in the circuit. So this completes the numerical. Next, we'll move on to the next sum. Find the value of R1 and R2 in the following circuit. So this also has been asked in the Mumbai University question paper, November 2018. So this is a circuit which I have read on it here. So they have asked to calculate what is the value of R1 and what is the value of R2. Okay, again we will assume the direction of the current to be clockwise. So this I have assumed to be I1 in the clockwise direction. The next I have assumed this to be as I2 and this is to be I3. So from the circuit, what you can see, okay, I2, you can see here I2 is already given in the equation which is equal to 10 amps. So I have written I2 is equal to 10 amps. And from this circuit again I3, there is a 5 amps given. Okay, I will directly write I3 as 5 amps. And between the meshes 1 and 2, there is a 3 amps common current source is there. So this will form a super mesh which I have indicated in a green line. Okay, so from this what you can get the I2 minus I3 is equal to I2 minus I1 is equal to 3. So how do you get this? You get this by applying a KCL at this node. So at this node there is an incoming current I1 Okay, at this node there is a outgoing current I2, and at this node there is an incoming current of 3 amps. So incoming is, if I write incoming is I1, incoming is 3 amps, which is equal to outgoing, which is the I2. So from this equation, by rearranging, so this equation can be rearranged as I2 minus I1 as 3, which I have written it here. Okay, from here again, I2 value we know, which is equal to 10. So substitute the 10 value, we get the value of I1 as 7 amps. Now applying KVL to the mesh 3. So when I apply KVL to the mesh 3, I get 1 into I3. Okay, so this is the 1 ohm, so 1 into I3. Now minus R2, there is a current, we are going in the direction of I3. Opposite current there is a coming, which is I1. So it is I3 minus I1 I have written. So I3 ki value we know, that is 5 amps. So substitute the 5 amps. And from this equation, we will get the value of R2, which is equal to 2.5 ohms. And seeing this circuit, since the 3 amps current is common, okay, so this will form a super mesh, which I have highlighted in the green line. Okay, so applying KVL to the super mesh, what do you get? We'll start with 10 volt. So it is minus to plus, it is going, so it is plus 10. Then there is a minus I1 R1, which I have written it here. Then coming to this, it is minus 5 I2, minus 5 I2. Then this super mesh goes to R2, R2. We're going in the direction of I1, and there is opposite current coming, which is I3. So it is I1 minus I3. So we know the value of I1. Okay, we know the value of I2 and we know the value of I3. So we need to put these values, and from this only variable is R1 in this equation. So we get R1 to be 6.4 ohms. Okay, so it is in this circuit. So we get R1 to be 6.4 ohms minus 6.4 ohms. So this completes the numerical. Okay,